Welcome to Fluid Mechanics and Hydraulic Machines Laboratory. Today, we are going to conduct an experiment to determine the coefficient of discharge through an ogee weir. A weir is an obstruction which is constructed across an channel. The weirs can be classified based on the shape into two types. One is the broad-crested weir and the other one is the ogee weir. Ogee weir is used as a spillway over a dam. The ogee portion facilitates easy rollover of water from upstream of dam to the downstream and protects the dam body from the erosion. This is the experimental setup of the ogee weir, where the ogee weir, which is an obstruction, is built across the approach channel. Note down the width of the ogee weir, and before allowing the water to flow through the weir, note down its head with respect to the crest point of the ogee weir. Note down the main scale reading and vernier scale reading to calculate the H1 value. Switch on the pump and allow the water to flow through the approach channel. After a steady flow is attained over the approach channel, measure the head over the weir using the pointer gauge. The tip of the pointer gauge should touch the water surface. Note down MSR and the vernier scale reading to calculate H2 value. Close the outlet of the collecting tank and note down the time taken for a 10 cm raise in the collecting tank of water level. Conduct 2 to 3 trials for various discharge conditions and determine the time taken and also head with respect to the discharge condition. The observation and the calculation part of the ogee weir is as follows. First, note down the breadth of the collecting tank, which is taken as 0.3 meter, and the length of the collecting tank, which is taken as 0.3 meter. Therefore, the area of the collecting tank is the product of the breadth and length of the collecting tank, which will be 0.09 meters square. The theoretical discharge over a ogee weir is given by the formula Q theoretical is equal to 2 by 3 into L into root 2G into H to the power 3 by 2, where L is the width of the weir, which is taken as 0.2 meter, and G is the acceleration due to gravity, which is 9.81 meter per second square, and H is the head at the upstream of the weir, which is given by the formula H is equal to H1 minus H2, where H1 is the height of the crest of the weir and H2 is the head of the water above crest point of the weir. H1 and H2 is calculated using a pointer gauge, where the calculation part is shown in the broad-crested weir video. Therefore, H1 is 0.0514 meter and H2 is 0.0356 meter. Therefore, H, that is the head over the ogee weir, is given by the formula H is equal to H1 minus H2, which becomes 0.0158 meter. The cube theoretical with respect to ogee weir is calculated by the formula 2 by 3 into L into square root of 2G into H to the power 3 by 2, where H is the head over the weir, which is taken as 0.0158 meter. L is the width of the weir, which is taken as 0.2 meter. Therefore, if we substitute the length of the weir value and head over the weir value, the Q theoretical will be 1.173 into 10 power minus 3 meter cube per second. The actual discharge through an ogee weir is given by the formula Q actual is equal to A into R divided by T, where A is the area of the collecting tank, which is taken as 0.09 meter square, R is the rise of water level in the collecting tank, which is taken as 0.1 meter, and T is the time taken for the rise, that is 10 centimeter rise in the collecting tank. For the first discharge condition, the time taken was 10 seconds. If we substitute the values of A, R and T in the Q actual equation, the Q actual will be 9 into 10 power minus 4 meter cube per second. The coefficient of discharge is given by the formula CD is equal to Q actual by Q theoretical, where Q actual is equal to 9 into 10 power minus 4 meter cube per second and Q theoretical is 1.173 into 10 power minus 3 meter cube per second. If we substitute, the CD value will be 0.76. Conduct different trials with respect to varying discharge condition and calculate the average coefficient of discharge.